So in this video, I'm actually going to help you guys out with number 3. I'm not sure, well, I do know why I feel like bailing you out. It's because right in here, this is a little bit tricky to solve this guy. We've got to divide by t squared before we do this problem. And then there's one other kind of sticky part at the very end. And I wanted to talk about those. All right, so the first thing that this question asks is to verify that this function, t squared, and t to the negative 1 satisfy the homogeneous part of the differential equation. So what that means is that we're going to show that they're a solution. So we want to show it's a solution to the homogeneous differential equation, which is this ty double prime minus 2y equal to 0. So we want to do this with both functions. So the first one being t squared, and so if we're going to plug it in here and show that it works, we have to take a second derivative. So here's a first derivative, which is 2t, and then here's a second derivative, which is 2. And now I'm going to plug in this second derivative in y and see if this works. All right, so t squared times the second derivative, which is 2, minus 2 times our y value, and our y1 was t squared. And sure enough, 2t squared minus 2t squared equals 0. So that's a solution. So I'm still going to leave it up to you to verify that this one, the y2, is a solution, but it's the same idea. You take a second derivative, you plug it in, you show that it's 0. All right, so now on to finding the particular solution to this thing. I'm going to pop up kind of our equation for variation of parameters here. Okay, so you can see that in this, the solution to y double prime, there's no t squared out in front of this one. So really, in order to even start to use this equation, we've got to divide everything by t squared. So that's going to give us a y double prime minus a 2 over t squared y is equal to 3t squared minus 1 all over t squared. And that right-hand side, if I simplify it just a little bit, this is going to help us later with our integration. That right-hand side is 3 minus t to the negative 2. So I divided t squared into both terms there. So what this gives us is our g of t in order to plug it into this equation. We have our y1 and our y2. Our y1 is t squared and our y2 is t to the negative 1. And then we need our Wronskian, which is the determinant of our y1 and our y2 and their derivatives, 2t and then negative t to the negative 2. So if I multiply down, I've got a t squared times a t to the negative 2. So that just becomes t to the 0, which is 1. And so then multiplying down, I've got a negative 1 minus the multiplication up here. I've got a t times a t to the negative 1. That's a t to the 0, which is 1. And that has a 2 out in front. This is equal to negative 3. So our Wronskian is negative 3. All right. I'm going to go to a new page here. Okay, so I've written down, I have our equation here, I have our y1, our y2, our g after dividing by that t squared, and our Wronskian. Now we have to plug everything in. This one does just ask for the particular solution, so I'm not going to worry about that homogeneous part of the solution. So the particular part of the solution is going to be negative our y1 times the integral of our favorite number, I just make it 0 to t, of our y2. So I'm going to transfer over to x's because that's my favorite variable instead of s's. So x to the negative 1 times g, so that's 3 minus x to the negative 2 all over negative 3. Then plus our y2 times the integral from 0 to t, y1 with x's, g with x's, and divided by the Wronskian. All right, do a little simplification here before we integrate. So let's see, this first one, it's just going to be an x to the negative 1 and a negative, because those 3's would cancel. Then I've got a negative 3 divided by a negative, so that's a plus. Looks like we're going to have a 1/3 there. There's no 3 to cancel with that second term. And an x to the negative 3. And then in this second one, if I multiply through, 3 is going to cancel with 3. That's going to give me a negative x squared. And negative is a plus 1/3. And I think that's all I'm going to get there, because x to the x squared times x to the negative 2 is going to be x to the 0, which is 1. Okay, time to integrate. So on this first one, if I integrate x to the negative 1, looks like that's going to give me a natural log of x. And then the second one, if I add 1, I get an x to the negative 2. And then divide by negative 2. All right, and I'm going to have to evaluate that from 0 to t. On the next one, I've got, let's see here, I've got to add 1, divide by 3 then, and the integral of 1/3 is 1/3 x, and I'll have to evaluate that from 0 to t. All right, let me do some evaluating. So I'm going to plug in t. And if you remember, I am not going to plug in 0, because I know that if I plug in 0, I get some number. Well, first of all, it's illegal, right? I can't even do it. Maybe I'd have to switch it to 1, because I can't even plug 0 into natural log. So even if I plugged in 1, I would get some number times t squared. So I've got a t squared and some number, whereas up here I've got a t squared times a c1. It gets absorbed into this. It doesn't matter anyways. So I'm not even going to plug it in. Plus, I'm going to plug in t, and again I'm not going to plug in 0. So I'm going to have a negative t cubed over 3 plus 1/3 t. Let me multiply some stuff through. So I've got a t squared, natural log of t squared times t to the, that negative didn't come through, t squared times t to the negative 2 is t to the 0, which is 1, and then I've got a negative times a negative, so I've got a plus 1/6. Then here I'm going to have a minus t squared over 3, and looks like a plus 1/3, because I've got a t to the negative 1 and a t. I can combine some stuff together. The 1/3, or 1/3 and the 1/6, and 1/3 plus 1/6 is 1/2, right? Because I'm going to have, so that's 2/6, 3/6, yeah, minus t squared over 3. All right, and then we're almost there. We didn't take into consideration the homogeneous, but this term right here is part of the homogeneous differential equation, because it is a constant times that y1. It's a constant times y1. So it would just get absorbed into that constant. And so what's left for our particular, what's left that is not part of our homogeneous, it is not a t squared and not a t to the negative 1, is t squared natural log of t plus 1/2. Boom.